All right, let's dive straight into our explainer for Chapter 12, Ticking Clocks and Turning Calendar. Time is just one of those things we interact with literally every single day of our lives, right? But we rarely stop and think about the actual intricate systems we use to track it. So today, we're going to break down exactly how we measure the passage of time. We'll go from the grand scale of years all the way down to the exact minute on a ticking clock.
Now check out the date for Parv's birthday party here. It's February 29th, 2024. Have you ever met someone who claims they only get to celebrate their birthday once every 4 years? Well, Parv is actually one of those special cases. And this specific date is honestly the perfect starting point for us because it introduces a pretty brilliant little quirk in our calendar system.
To completely demystify how all this works, we'll journey from the macro scale of turning calendars right down to ticking clocks. We'll be covering the calendar and leap years, real-world dates, tracking the hours, AM/PM versus digital time, and finally, elapsed time. So let's get right into it. Kicking things off with Section 1, the calendar and leap years. Let's go ahead and solve the mystery behind Parv's super unique birthday.
So, the crucial thing to remember here is that most standard years have exactly 365 days. But, fun fact, the Earth's orbit around the Sun actually takes about 365 and a quarter days. To make up for that extra quarter of a day, we just add them up over time, and then every 4 years, boom, we get one full additional day. This creates what we call a leap year, giving us 366 days in total. And where do we stick that extra day? Right at the very end of February. You can easily see the difference if you just compare a calendar from 2024 to 2025. Since 2024 was leap year, February stretched all the way out to 29 days. But if you flip over to 2025, which is a standard year, February just stops at 28 days. It's a super simple adjustment, really, but it's absolutely crucial because it keeps our calendars perfectly aligned with the seasons. Moving right along to Section 2, real-world dates. Let's see how this all applies to our daily lives.
You can actually practice reading dates right at home. Just check the manufacturing and expiry dates printed on everyday items, like a box of biscuits or maybe a carton of milk. These dates are typically written in a format like DDMMYYY. That stands for day, month, and year. It's basically how manufacturers communicate a highly specific pinpoint in time directly to you, the consumer.
And by understanding these calendar formats, you can start answering some pretty critical practical questions. Like, if you know today's date, you can just subtract the manufacturing date to figure out exactly how old that packet of biscuits actually is. And, probably more importantly, by comparing today's date to the expiration date, you can calculate how many months and days those biscuits are still safe to eat. This is literally practical math that we use to navigate our everyday lives.
All right, on to Section 3, tracking the hours. We're zooming in from the calendar right down to the clock face.
Take a look at this detailed schedule tracking a doctor's daily activities. We can see the whole cycle here. Waking up at 6 in the morning, going off to the hospital, cooking, spending time with the kids, sleeping, and eventually reaching 6 in the morning all over again. It perfectly represents one complete cycle of a daily routine. And here's the cool part. If we count the total duration of all those activities, from 6 o'clock one morning to 6 o'clock the very next morning, we find out there are exactly 24 hours in a single day. No matter how you slice it, whether you think of it as 12 hours of daylight and 12 hours of nighttime, or maybe you're working different shifts, one full rotation of the Earth gives us a 24-hour block to live our lives.
Which brings us to Section 4, AM/PM versus digital.
So notice how the clock shows exactly 8 o'clock in both of these scenarios, but the environments are completely different. When the sun is shining bright, it's breakfast time. But when the moon is out, it's dinner time. To solve this little 12-hour overlap, we add AM to indicate morning time under the sun and PM for afternoon and nighttime under the moon. AM basically covers the first 12 hours from midnight up to noon, and PM covers the second 12 hours from noon right back to midnight.
But, there's actually another way. Digital clocks help us read time even more clearly by using a continuous 24-hour format. Notice how 12 p.m. stays 12 hours. But once we hit 1 p.m. in the afternoon, the digital clock just keeps on counting up. It becomes 13 hours. 5:20 p.m. becomes 17:20 hours. You literally just add 12 to any p.m. time. It's a brilliant system because it completely eliminates the absolute worst mistake, accidentally setting your morning alarm for 6 p.m. instead of 6 a.m. We've all been there, right?
All right, finally, we're at Section 5, elapsed time.
Here is a fantastic everyday problem you've probably encountered yourself.
Let's say Raghav leaves his house to go to the market for some milk at exactly 8:20 a.m., and he gets back home at 8:35 a.m. How do we actually find the total amount of time he spent running that errand?
Well, by tracking the forward movement of the minutes on the clock, we can easily visualize that passage of time. Think of it in little jumps. From 8:20 to 8:25, that's 5 minutes. From 8:25 to 8:30, that's another 5 minutes. And from 8:30 to 8:35 is 5 more minutes. If we just add those 5-minute increments all together, we can easily see that exactly 15 minutes have passed. Easy, right? And the great thing is, we can apply these simple chronological steps to literally any activity. Let's say Munira wants to read for exactly 45 minutes, and she starts at 4:15 p.m. We just add that duration right onto her start time. So the first 15 minutes takes her to 4:30 p.m., and then the remaining 30 minutes takes her perfectly to the top of the next hour. By logically stepping forward through the minutes like that, we can easily figure out that Munira finishes her reading session at exactly 5 p.m. So, now that you know exactly how our standard time is measured, from the grand span of a leap year all the way down to an elapsed 15 minutes, I want to challenge you to look a little bit further. Think about how time is really just this fascinating human construct we use to track the celestial bodies above us. I highly encourage you to explore other community calendars, like the Hindu, Islamic, or Sikh calendars. Ask yourself, when do their years begin? How do they track the cycles of the full and new moons? What amazing new patterns will you discover when you look at time through a totally different cultural lens? Thank you so much for joining me on this explainer. Keep observing those clocks and calendars around you, and as always, stay curious.